Okay, welcome to Let's Get to the Marks. We're looking at 7.8 of the 2023 Paper 1 A-Level Chemistry, and this is on hydrated salts, and it's all about working out the integer x, and it's a big fat question worth 7 marks, 7 whopping marks. So let's get into this one and check it out. Right, let's get this whole question in view. Hydrated aluminium sulfate Al2SO4 3.X H2O is soluble in water. The relative formula mass and value of X can be found from a titration experiment. Aqueous AlH2O6 3 plus ions react to form a stable complex when treated with an excess of EDTA4 minus ions. The excess EDTA4 minus ions is determined by titration with zinc sulfate. The method: dissolve 1.036 grams of aluminium sulfate hydrated in distilled water and make up to 250 centimeters. So straight away, look, we've been given the mass, and that is immediately making me feel like we are going to need our mass over mR times moles. And so we immediately want to note that as we go through. And it says make up to 250 centimeters, then add 25 centimeters from the 250. So what I want to know here is I've gone from 250 centimeters to 25. So I've kind of had a bit of a dilution here, or not really a dilution, but I've taken a portion. It's not really a dilution, but we've taken 25 centimeters of 250. So I just want a little note there, something that's going to trigger me later on to remember that. Of this solution, we're going to add that to 50 centimeters containing EDTA4 minus ions of a concentration of 0.01 mole per decimeter. Now, what have they given me? Mole per decimeter. What does that unit tell you? It tells you you're dealing with concentration. So I want to put on my second triangle here, which is N over C times V, because they're giving me concentration. So now we're starting to get cooking on gas. Determine the excess of EDTA4 minus ions by titrating with zinc sulfate solution in the presence of an indicator. The excess EDTA4 minus ions require 18 centimeters, that's our volume, and 0.0105 mole per decimeters to react completely. Look, I've been given a volume and a concentration, so we've got a great starting place here where we can work out moles. The equations for the reaction are hard. We got two equations. We got 1 and 2. So we've got two equations going on here. Whenever you get two equations in a titration, you're looking at what we call a back titration. And this is where you calculate the excess EDTA and you subtract it from the original volume of EDTA, which we can work out here. And what that does is that allows us to work out how much EDTA reacted in the first equation and work out your missing moles. So let's get into it. We've also been given the MR, which confirms we're going to have to use this equation here. So where do you start in a big dirty 7-mark equation like this? Well, there's a couple of starting points. We've been told we had 50 centimeter cubed of EDTA4 minus there. So I could actually calculate the original EDTA4 minus, or I could start down here at the back and work my way up. I tend to start at the bottom and work my way up. If you find these difficult, just start at the bottom and work your way up through the data. So that's why we call them back titrations. So start at the back. So I'm going to work out the excess EDTA4 minus, and we're going to do that. Let me change the color so it stands out a bit more. We've got volume times concentration equals moles. So I'm going to do 18 divided by 1,000 times the concentration of 0.0105. And this is going to give me my moles, which is 1.89 times 10 to the minus 4. Now, what this has told me, this is the moles of excess EDTA. So I want to label it as well so I know actually what I'm banging on about. So this is excess EDTA. Okay, I'm going to skip the 4 minus for ease. So that's the excess EDTA. If we go down to this equation, we can see that that's in a 1-to-1 reaction with the zinc. But actually, that was the zinc solution I've worked out. So getting myself in a muddle there. But that does tell me, it doesn't really matter because they're the exact same, but this was the zinc sulfate solution. And they're actually in a 1-to-1, as you can see there. So because they're in a 1-to-1, that also tells me I have 1.89 times 10 to the minus 4 moles of excess EDTA because they were in a 1-to-1. Now I know the excess EDTA. Let's work out the original EDTA by coming up here to the 50 centimeters with 0.01. And then I can subtract the excess from the original to get how much EDTA was used in this first equation. So we're going to do original EDTA was 50 over 1,000. Why am I doing that? Because we need to turn centimeter cubed into decimeters. And I'm going to times that by 0.01, and that is going to give me the original EDTA, which is 5 times 10 to the minus 4, and that is the moles of original. Now I want to find out the reacted EDTA. So reacted EDTA is equal to the original minus the excess. And so I want to do the original, which is 5 times 10 to the minus 4, take away 1.89 times 10 to the minus 4, and that is going to give me my reacted EDTA, which is 3.11 times 10 to the minus 4. So my reacted EDTA, this is how much was used up. So this is EDTA that reacted with AlH2O6, right? So that is how much EDTA reacted over here. Now we can tell that's a 1-to-1. So that means I also know now that I had 3.11 times 10 to the minus 4 of Al H2O 6, right? So that's how many moles of that I had. However, we're dealing with aluminium sulfate here. Look, aluminium sulfate. So what I need to know is that this one molecule of this aluminium complex ion only has one aluminium atom in it, whereas there are 2 aluminium atoms in aluminium sulfate. So if I want to find out how much aluminium sulfate produced this, I need to divide by 2 because, excuse me, these bad boys have 2 aluminiums in them. So these aluminium sulfates have 2 aluminiums. So I need to divide by 2. So let's do that. That's 3.11 times 10 to the minus 4 divided by 2. And that is going to give us 1.55 5 times 10 to the minus 4. So we're going to get, I have 1.55 times 10 to the minus 4, and that is my moles of aluminium sulfate. Now, we've worked our way up to here. Here's where the next problem is. The next problem is that this is in 25 centimeter cubed. That's how many moles of aluminium sulfate I have in 25 centimeter cubed. What I need to do is times that by 10 because we're looking at how many moles of aluminium sulfate were in 250 centimeters cubed. So let's times this by 10. And if I times by 10, we're going to end up with 1.55 times 10 to the minus 3 moles. And that is aluminium sulfate in 250 centimeters. I now want to turn that into grams. Now you might say, why do you want to turn that into grams? What I'm trying to do here, I know the total mass of water in aluminium sulfate was 1.036 grams. So if I can find out how many grams of that is aluminium sulfate, I'll know how many grams I've got of water, and then we can work out the moles of each. So this is my moles of aluminium sulfate, right? God, it's long doing this, and that is scrappy. That's my moles of that. Let's work out my moles of water. So I want to times this by 342.3 because this is the MR of aluminium sulfate. So times 342.3, and we're going to get, I have 0.53 grams of aluminium sulfate. So let's do 1.036 Let's take away the 0.53 grams, and we're going to find out how much of this Al2SO4 3.xH2O is water. So let's do 1.036, take away answer. We're going to find out that we have 0.503 or 504 grams of H2O. So how does this help us work out what X is? If we just look at mass for mass, it's almost a one-to-one in terms of mass, right? Because I've got 0.53 grams of aluminium sulfate and I've got 0.503 grams of water. However, that doesn't tell me what X is, because X, okay, is going to be telling us the ratio of the moles of aluminium sulfate to the moles of water. So I need to compare my moles of aluminium sulfate, which is 1.55 times 10 to the minus 3 to my moles of water. Well, what are my moles of water? Well, I need to take the grams, 0.503 grams, and I need to divide it by the MR of water. Hopefully you can remember the MR of water off by heart. You should know it now. You're doing A level. H is 1, O is 16. So I got two H's and an O. That is 18. So 0.503 grams divided by 18. And we are going to get, we have 0.027 moles of water. Okay, and I got this many moles of aluminium sulfate. So what's the ratio between those? Well, what I'm going to need to do, I'm going to come all the way down to the bottom left because I've run out of room, which is a bummer. And I need to divide the big number by the small number. So 0.027, I've got more moles of water than I have aluminium sulfate, because this is 0.05155 or 1.55 times 10 to the minus 3. And then let's see what that ratio is. So I'm going to go 0.027 divided by 1.55 times 10 to the minus 3. And yeah, and we get roughly 18. So that tells us that there are 18 molecules of water for every molecule of aluminium sulfate. So although the masses were roughly equivalent of aluminium sulfate to water, we had about 0.5 of each. When you convert that into moles, we've got 18 times more moles of water than aluminium sulfate, so X is 18. Like, share, subscribe. Let's get to the marks.
You're still here? It's over.